All right, welcome back to Mr. PL's for Precal. This is Unit 2, Topic 2, Lesson number 3. Once again, solving and applying, we're once again solving and applying for exponential and logarithmic equations. So we've got some basic equations here that we have already done before, so we can use inverses. So this would be log base 8 of both sides, because that's the inverse of 8 to the power of. So that gives me x equals log base 8 of 4. And I'm going to leave it just like that because that's the precise answer, which will be the same thing as log of 4 over log of 8 if you want to use change of base property, and then you can put it into the calculator and round it to the nearest decimal. Over here, natural log of both sides, x equals natural log of 5. This one I would add 14 to both sides. That gives me 3 times e to the x power equals 25. If I divide both sides by 3, now 25 doesn't divide by 3 equally, so I'm going to leave it the way it is. E to the x power equals 25 thirds. Natural log of both sides cancel out, and there's your answer. So natural log of 25 thirds. This one's going to be 10 to the power of. That's the inverse of log base 10, would be exponentiate 10 to the power of. That cancels out. 3x plus 1 equals 100. If I evaluate this, 10 to the second power is 100. Subtract 1 from both sides, and you get 3x equals 99. Divide both sides by 3, and you get x is 33. All right, so moving right along. So we're going to be solving these 3 different ways, and it basically comes down to the exact same answer. And what you see is that, like change of base property, it really doesn't matter what the base is, as you'll see here in a second. So what if we do log base 10 of both sides? So that would be just log of 2 to the x equals log of 15. Now I'm going to use product property and push the x out front, so that gives me x times log of 2 equals log of 15. Now I want to isolate the variable, so I divide both sides by log of 2. And this is divided by log of 2. Now keep in mind, it's log of 2, not log base 2. So you got to be careful with writing your numbers, because that kind of looks like I wrote it kind of small like a base, but it's not. These cancel out, and you're left with x equals log of 15 over log of 2. Then that you can put in your calculator, and you can see exactly what the decimal is, which I'm not going to do right now, but I will leave that to you to do, and you can put your result right down here. I'm going to do the same thing now using... I just used common log. Sorry. All right. So imagine I put this here. I just realized I did it backwards. And now I'm going to do this, which is solving using inverses. Well, the inverse of 2 to the power of would be log base 2 of 2 to the x. And this would be log base 2 of 15. So these cancel out. So x equals log base 2 of 15. Now, this ends up being, if you put this in the calculator, which your calculator may or may not be able to do this, you're going to get the exact same decimal. And that was the whole point of this, is that no matter which one you do, you're going to get the same answer. Because this is really log of 15 over log of 2 using change of base property. And last but not least, what if I do natural log of both sides? Natural log of 2 to the x equals natural log of 15. Push the x out front, so we have x times natural log of 2 equals natural log of 15. And then divide both sides by natural log of 2. I know my handwriting is bad here. And you're going to end up with basically the exact same thing as before. So natural log of 15 over natural log of 2. You can change the base, because you can really say that the base here and here are going to be anything you want as long as they're the same on top and bottom, and it's going to equal to the exact same thing. Every graphic calculator should be able to put this into it and press enter, and you'll see that all 3 of these have the exact same results. All right, so this is exactly the same as the other one, so I'm going to skip it. Divide both sides by 5 first, gives you log base 2 of x minus 3 equals 3. And then exponentiate. This gets rid of that, and this becomes an 8. Add 3 to both sides, and you get 11. If you plug 11 back in for x, you'll see that it works. 11 minus 3 is 8. What power of 2 is 8? That would be 3. 3 times 5 is 15. It works. Subtract 3 from both sides, you get 2e to the negative 3x equals 18. Divide by 2, you get e to the negative 3x equals 9. Natural log of both sides, and you got negative 3x equals natural log of 9, and divide by negative 3. So x is negative 1/3 natural log of 9. Over here, subtract 4 from both sides. You get 3 times 2 to the x power is 21. Divide both sides by 3. 2 to the x power equals 7. And then log base 2 of both sides. And there's your answer. X is log base 2 of 7. All right. Moving on to the classwork that I assigned for this was the CUDA worksheet, which once again you can find online. So it starts off very easy because they're both log base 10, so really you can exponentiate both sides, and that basically cancels out here and here. Then you're left with 3x minus 9 equals 2x plus 6. And now from here is basically just an Algebra 1 question. So move the variables to the same side. X minus 9 equals 6. Add 9 to both sides. You get x equals 15. One more of these. Same thing. Exponentiate. And you get this. Subtract. No, actually, I want to move the smaller one. So add 4 to both sides, you get 7 equals 7n. Divide both by 7, you get 1. Let me skip some of these easy questions, go to a mediocre question. These are all bases that are the same on both sides, so that's what makes it kind of easy. So you can exponentiate both sides to 19, and then you're left with just 3 minus 3r squared equals negative 2r squared minus 6r. Now, the reason why I've chosen this one is because it does have a squared involved, and so do these, actually. So if I add 3r squares to both sides, and then I've got 1r squared minus 6r equals 7. And then I'm going to move everything to the right and subtract 7. So 0 equals r squared minus 6r minus 7. And then I'm going to ask myself, is this factorable? Is there any two numbers that give you negative 7 and add up to negative 6? And that'd be negative 7 and 1. So this is r minus 7 times r plus 1. And then that means you got two answers. You got negative 1 and positive 7. Now you always want to check to make sure that neither of those answers are extraneous, meaning if I put these numbers in for inside the parentheses, it should never be a 0, nor should it ever be a negative, because then it wouldn't make any sense. So if I put 7 here, 7 squared is 49, negative 3 times 49 is going to be a much bigger number. So this is not going to work. If I put negative 1 right there, it becomes 1, and 1 times negative 3 is negative 3, and that works, check. And if I put negative 1 here, negative 1 squared is 1, 1 times negative 2 is negative 2, negative 2 plus 6, it does work. Okay, so negative 1, this is that rare case, we haven't seen this question before, where the negative actually is the real answer, and the positive one was the extraneous solution. And, oh, that was it. All right. Thanks again for watching, and look forward to the next video.